All right, welcome back. This little presentation here is not too long, but it's going to be on two very important things: hierarchy of controls and a risk matrix. These kind of work together somewhat, and you're going to get some practice on them in the next module. But you got to know them; they're very important in your career. You'll use them a lot. So, hierarchy controls and risk matrix. Two concepts, again, that are used throughout safety, and you really need to have a firm grasp on them. Very important. There you go. See that? This thing knew what I said before I even said it. Thank good. All right, this is their hierarchy of controls. Now, it starts at the most effective at the top, and that's elimination. And that's physically remove the hazard. If you can just get rid of it, no hazard. Well, that's the best thing you could do, right? Get rid of it. And it's not always, you can't always do that. Substitution will be the next thing. Replace the hazard. Maybe you can replace it with something less. Obviously, you won't replace it with something more hazardous. You want to replace it with something less hazardous. And that'll be next. Engineering controls will be next. And that isolates people from the hazard. Or the hazard's there, but you just can't get to it. Administrative controls changes the way people work, training and that type of thing. And PPE, protect the worker with personal protective equipment, is at the bottom of the hierarchy of controls and the least effective. So we're going to go through each one of these. There's some others out there, hierarchy controls. Some will add warnings between engineering and administrative, but I consider a warning and administrative controls. We're going to see one later on in this course that the authors used that has warnings in there, but that's pretty minor. But I like the one that we just looked at. So we're going to start at the top. Elimination, physically remove the hazard. And again, substitution, replace the hazard, obviously with something less hazardous. Now, these two are much easier to implement if they are addressed in the earlier planning stages of a project. Once something's up and running and going, it's pretty hard to get rid of it completely or substitute something for it. So they're not going to come into play as much on a daily basis as the other three are, but they are there and they should be considered. So again, once something's a going concern, it's much more difficult to either eliminate or substitute something. And there you go. There it is again. So the next three items are the ones that will most likely be used in regular normal operations. Engineering controls, isolate people from the hazard. Examples are machine guarding and interlock. That's the most common one, a machine guard. You have moving parts there. You have a guard there so people can't get to it. You're isolated from the hazard. Very effective. The nice thing about this, engineering controls, they're there. They're always there. That guard's going to be there. Now, can somebody take it off? Of course they can. But that guard, normal use of that piece of equipment, that guard is going to be there. Administrative controls change the way people work. Training, policies and procedures, job rotation, warning signs, that type of thing, change the way people work. What's the problem with that? Well, you got to train them. You got to have them. You have to write a policy, you have to write a procedures, that type of thing. So there's a lot goes into this, and it has to be communicated with the people, and they have to use it. But there's a lot. But you have to have them. Just about the whole OSHA regulations are administrative controls. So you have to have them, and they must be thought out and done and be clear and concise, and people must be trained in them, and they must follow them. Personal protective equipment, protect the worker with personal protective equipment or PPE. Again, the last line of defense. There's a lot of PPE out there. Some are hard hats, safety shoes, safety glasses, fall protection, welding hoods and clothing, protective gloves, hearing protection. There's a lot of PPE out there. So we'll talk about some problems with PPE in a minute. So pros and cons here. The most effective in the hierarchy control starts at the top, elimination and substitution. Of course, you can get eliminated completely. But again, these two are usually easiest to do in the planning stages and much more difficult to do in an ongoing operation. Of the bottom three, engineering controls are best because they usually don't require the employee to do anything. They're just there. So when the employee comes to work, they're working on a piece of equipment. There's a guard there protecting it from the dangerous parts of the equipment, the hazardous parts of the equipment. They don't have to do anything. It's there. And that's the nice thing about engineering control. The engineering controls sometimes can be a little more expensive up front, but then they're there for the life of the machine, usually. Administrative controls must be formulated. People must be trained in them and use them. So there's a lot of work that goes on with administrative controls too. So, and PPE requires the user to do something, and they must be trained how to put it on, use it, take it off, clean it, care for it. And sometimes getting them people to wear it's a problem. So there's a lot of problems with PPE, but again, you got to have training in it too. So in most manufacturing industries, they're going to be a mix of you'll use or come across a mixture of engineering controls, administrative controls, and PPE. So here's a scenario that could easily happen to you when you're in the safety department. Your company acquires a new piece of equipment. Maybe it's a new company even or something like that. So a discussion started as how to make it safer. So you immediately take the lead on this conversation and start at the top of the hierarchy controls, and you steer this decision-making process in a sensible and intelligent manner. And that's the way to do it. This is a good piece of equipment. That'd be a good piece of advice. You got something you can use, a good tool you can use. Okay, here's what can we do this? Can we eliminate it? Can we substitute something for it? No. Can we guard it? No. Can we train people on how to use it? All the way down. And you might have a combination of things. There might not be equipment might need to have guards on it and be noisy, and you might have to have PPE and engineering controls, usually for different hazards, of course. So that's briefly how that hierarchy controls works. You're going to use it a lot. You're going to see it a lot. Next is the risk matrix. Now if you go up and search risk matrix on the internet, you're going to see a whole bunch of these up there. They're all over the place. In process safety management, we used a 4x4 matrix, mainly because that's what the one that the ammonia industry used. So did our consultant doing a process hazard analysis. And we'll talk about PSM much, much later in this course. But I prefer the 5x5 one, which we're going to use in this course. So we're going to look at it and then discuss it. You'll see what I mean by 5x5. You see it has 5 levels here and 5 up here. So that's 5x5. Again, there are, I'm going to guess, thousands of permutations of this, but they all have pretty much the same basic. And we're going to look at each part of it a little closer. We're going to start at the left, the severity level. One thing I like about this particular risk matrix is that it was 3 different categories of incident outcomes. See right here. See, here's your incident outcomes. 3 categories: health effects on people, property damage, environmental impact. Because when you're doing this in real life, so to speak, sometimes that's what's going to happen if things go wrong. You might have environmental damage impact or property, which might not be just health effects on people, or it could be a combination. But this gives you kind of an idea then. So there are 3, there's the 3: health effects, which is people, property damage, and environmental impact. An event could have an impact on any one or more of these categories, but usually the predominant outcome will be just one of them. And here are the health effects: people. 1, the lowest is first aid or no injury illness. 2, injury illness with no lost work days. 3, injury illness with 1 or more days away from work. 4, permanent partial disability, hospitalization of 3 or more people. And 5, death or permanent disability of just 1 person. So that's the 5 health effects. Next is property damage, and this is pretty simple: light, moderate, significant, severe, catastrophic. Environmental impact: light, moderate, reversible, significant, reversible, and significant. And the last one would obviously not be reversible. So now let's move to the likelihood of occurrence reading across the top. The likelihood. Now we talked about severity. Now we're talking about likelihood. Those are the 2 5s in the 5x5 matrix: severity and likelihood. So across the top, very unlikely is the lowest, unlikely, possible, likely, very likely. The number selected for severity levels then multiplied by the number selected for likelihood of occurrence to get the risk number. So there you go. And this number is multiplied by this. So obviously 5, 1 times 1 is 1. So 5. And of course, this 5 is going to go up every time. 5, 10, 15, 20, 25. 25 is like very, very likely and very catastrophic. So if you cast something that's a 25, well, you better jump on that sucker right away. And so you can see how that works. pretty simple. The bottom of the chart, at the bottom of the chart, the risk numbers are ranked 15 or greater, very high risk, 10 to 14, high risk, 5 to 8, moderate risk, 1 to 4, low risk. The product of this student is entered into the appropriate square, the color coding, just to make it easier to read. So hierarchy controls a risk matrix. So why do we go through all this? Well, it's important to analyze risk outcomes and occurrences to establish which produce the highest risk and to rank those risks so they can be dealt with first. So you're taking something that's somewhat subjective and trying to get it into something objective so you can rank them. Or if you're not ranking more than one, you're at least going to find out how serious is this risk. So these are tools that you will most likely use in your safety career. And that's all there is to this. So look them over carefully. And in the next module, there's going to be some chances for you to get some experience on using them. In the meantime, you know what I want you to do. Be safe.